Welcome to RGES Algebra 2. This is lesson 8B and we're continuing on with factoring. Today we'll be discussing perfect square trinomials and difference of two squares. Okay, let's look at several examples here. Now we're looking for how to turn this trinomial into factoring. And if you see a pattern where the first one is something squared, m squared, and the last one is something squared, the last term in a trinomial. And if you multiply them together and you get 4 and you double it and you get 8m, then this simply becomes squared. Because if you, again, FOILed it out, you get m squared minus 4m twice would be minus 8m and plus 16. So we're learning to recognize a pattern. Always try to factor out a monomial first. So you're going to factor out a y, and you're going to get 4 minus 4y plus y squared. Now this is suspect to me because this is the square root of something, or the 4 is the square root of the square root of 2. I'm sorry, 2 squared equals 4. There we go. And y squared equals y squared. If I multiply them together, I get 2y, and double it, I get 4y, because this is negative, this will be negative, and my answer will be that. So I think that this is a review for you, so I'm going through it fairly quickly. Hopefully it is. If we have this, we don't have anything we can factor out of everything, but what's squared equals x to the 4th, and that would be x squared. What's squared equals 4, and that would be 2. If I multiply them together, I get 2x squared, and if I double it, I get that. So what am I telling you? If your first term is something that's a square, and your last term is something that is square, then always check to see if the middle term complies. And if it does comply to this pattern, then we become what we call the perfect square trinomial. This would be like a perfect square. This pattern is called the perfect square trinomial. Okay, let's do it again here. We'll have a factor out of 2. We'll get a to the 4th plus 2a squared b squared plus b to the 4th. Again, this would be something squared. This would be something squared. If I multiply them together and double it, I do get this. So this part of it is just the binomial squared. And then don't forget the monomial factoring up front. So let me see if there's anything else to show you about this. Numbers 9 through 25 odd are simply identifying or making the pattern fit or making the pattern work by filling in one of the terms. For instance, let me do one for you. They're asking what would the middle term need to be in order to fit the pattern. Well, if this were 3a and this were b, I'd need that double, the product doubled, so that would be minus 6ab. And so this is the answer you're filling in for the middle term there. So those, I think, are pretty straightforward. Let's see, number 27 or 28, looking at that section. I'll do 28 for you. Now this would be 4xa. No, I'm sorry, 2xa. Because if I square that, I'm going to get 4. And recall that exponents are added, so a plus a is 2a. On the back end, the last term, I would have 2. Yes, thought I copied that wrong. That's got to be 2b up there. And so this would be 2y to the b. Again, because if I square that, I'd get 4. And then y to the b would be, the exponent now becomes b plus b, or 2b. Now if I multiply that together, I will get 4xa ALGEBRA, and that's exactly what I have here. So this does in fact fit that. This fits the perfect square trinomial pattern. So work out the rest of those, and let's look at the 35 through 37. Actually, why don't you go ahead and try to do those the best you can, and we'll, when we review the answers, see how you did. All right, let's look now at 2.4. This is finding the difference of squares, of two squares. We have, might have something squared here. 18 doesn't make that obvious to me. That doesn't make it obvious to me, but always look for a common factor first. So my common factor here, if I pulled out a 2, I would end up with 9c squared minus 25. Now this indeed is something squared. It's 3c squared. And this is something squared. It's 5 squared. And so now, if I just simply did that, I would need a middle term when I squared back. That's what we did the last time. So that would not be the right answer. But if I multiplied it by this, and all I'm changing is the sign, then my middle term drops out. So this would be, that would be the answer to that problem. Let's look again here. If I had x to the 4th minus y to the 4th, this would be x squared, y squared. I would have to have opposite signs, do it again with opposite signs so that my middle term dropped out. Now this is as simplified as it gets, but this, however, is also the difference of squares. So this one will simplify out to x, now using the same pattern I had before, x minus y and x plus y. So this becomes a two-step problem, and your answer is like that. So you're always looking to see factor completely and see if you have any monomial that factors out before you start. So these, look at these as definitely as little challenge problems. You get better with them as you go, but try to make sure that you factor completely. So factor monomial first, if you can, and factor your pairs or your binomials completely. Okay. And so if you keep those two rules in mind, let's see how many you can do on your own. We'll check the answers together, work on the word problems very carefully by yourself before you wait for class. Okay, do not forget to take the notes on all of this. Write everything that I wrote down. As far as the sample problems, that just is one more way for you to practice it. In fact, I would recommend that you watch me do the problem, or when you see the problem, you put it on pause, try to do the problem, and then watch me do it. And you'll learn better that way. Okay, so bring all your notes to class, bring your homework, have a great vacation, and we'll see you in another week.